Hi everybody and welcome to this week's Lego Technic video. Last week I presented this tank which is able to be driven forwards, backwards, turn right and left just using one motor and one remote control channel. It's been a very popular video, and as a result I typically get many questions from people about how I actually go about designing my designs. And I get asked, do I just build it straight away just from pieces, or do I do some prototyping and design on the computer? Well, do a bit of both. I would normally first prototype some of the key components, in this case of this particular model, the gearbox design. Then after that I pretty much get on the computer and design the rest using my favorite program, which is a Studio from Bricklink. And now one of the things I find with the Studio, of course, and many other design programs, is when you put the gears together, they generally don't mesh correctly, because when you get your components, they're generally set at 0 degrees, and when you put another one together, they want to be at 0 degrees as well. And of course the teeth don't mesh correctly, they kind of overlap. And what you have to do, you have to rotate one of the gears manually within the program at the correct angle to get them to mesh correctly. So what I thought today, I'd talk about how I do that within Studio. There are a number of scenarios that you have to look at. Alright, so the first scenario I'll be looking at is simply where you've got two gears, one above the other, and you're trying to mesh the top one with the bottom one. So in this case I'm assuming that the top one is aligned at 0 degrees, it hasn't been rotated, and then we've got to somehow rotate that bottom one such that it will mesh. So of course if the bottom one's rotated at 0 degrees as well, then it doesn't mesh. We have to rotate that slightly in order for that meshing to happen. So all we need to work out, as you can see, is the amount of rotation we need in order for the tooth to line up with the gap. And that really comes down to working out how many teeth and gaps there are. We're just going to rotate effectively half a tooth around. So in this case it's a 16 tooth gear. We've got 16 teeth, 16 gaps. So what we need to do is divide 360 by 32, and then we get the answer here. So it's 11 1/4. So we need to rotate that bottom gear exactly 11 1/4 degrees, and then it will mesh perfectly with the top gear. So that's the case for two 16 tooth gears. Another example might be you might have a 20 tooth gear at the top and a 12 tooth gear at the bottom, and again if that 12 tooth gear is aligned at 0 degrees, it won't mesh, and we need to work out how much to rotate that by. So again, similar way, in this case we've got 12 teeth, so we've got to double that to get 24. We need to divide 360 by 24, and the answer is 15. So we need to rotate that bottom gear by 15 degrees in order for that to mesh. So okay, so that's scenario one, pretty straightforward. Okay, so the second scenario is where, for example, the top gear has been rotated by a certain angle, for example, maybe say 30 degrees, and we've got to work out how much we have to rotate the bottom one in order to keep that meshing. Well, the way I work that out, I simply think, well, let's assume we started at 0 at the top. That means the bottom gear would have to be rotated at 15 degrees like we calculated before. Then as I rotate this top gear to the angle that I'd like, then I can see that bottom gear rotating by a certain amount, and the amount that the bottom one rotates by, of course, is given by the gearing ratio, in this case 5 to 3, so it'll rotate 5/3 the amount this one's rotated will be the rotation of that one, and then you plus your 15 degrees to get your correct amount. So for example, like I say, we rotated that top one by 30 degrees, we multiply that by 5 divided by 3, that's the gearing ratio, add the 15, that would mean we'd have to have that bottom gear at 65 degrees in order to get the correct meshing. Okay, and the third and final scenario is where the second gear is offset relative to the first gear. So in this case I've got it offset by a 2 by 1 step, and the way I work this one out is I first pretend that they are vertically aligned correctly like this, with the top gear being at 0 degrees and then the bottom gear being at the correct angle to get the meshing. So in this case that's 11 1/4 degrees, and then I think about what happens as I rotate that lift arm into the correct position. So you can see that bottom gear is rotating relative to the top gear, and as I move it around it rotates more and more. So the amount of rotation is equal to that angle that I have to move it at. So in this case I have to work out that triangle, a 2 by 1 triangle, to work out that angle, and then I have to work out how much this gear rotates by. Now there's actually two effects going on. Not only is that gear rotating as I move the lift arm around like that, it's also physically moving in space. And what that means is that, for example, if it wasn't actually meshed, and I just move it out like this and remove the meshing, then if I've got a point here, say at the top of the gear, and I rotate it around 180 degrees, it actually ends up being at the bottom. So by doing this rotation, like I say, there's two effects. One is that the gear is moving and rotating relative to the lift arm, and it's also being rotated by the gearing. So those two effects add up. So you have to add up the amount that you rotated by. So in this case, if I work at this angle, I have to add that angle on from the physical movement, and then I have to multiply that angle by the gearing ratio and add that on as well in order to get the correct angle for that second gear. But I will illustrate some of this with an example from Studio, and I'll just do that now. Alright, so I've got Studio set up. In the corner I've got my scientific calculators allowing me to calculate the correct angles, and we'll just start with the scenario 1. That is where we've simply got a couple of gears meshed one above the other. So that's gear 1, we grab that one, put it underneath, and that is gear 2. Now when we zoom up, you can see that the teeth obviously don't mesh, and that's why we need to rotate one of them to get the correct meshing. Now of course you can just manually rotate like this and try to get the angle correct, but like I showed before, sometimes these angles aren't exact degrees. So when we calculate the correct angle, you'll find that quite often it's a fractional number. So in this case, this is a 16 tooth gear. We need to rotate half a tooth, so we need to take 360 degrees, divide by 32, and we work out it's 11 1/4. So that means we need to click on this one and rotate it 11 1/4 degrees, and then look at that, we get an exact mesh. So that's the example of two 16 tooth gears. I'll just also show you the other example where we've got a 20 tooth, for example, at the top, and again that's at a 0 degree angle, and we'll grab the 12th tooth and we'll put the 12th tooth underneath, and again we'll put them together like this. In this case, we get a collision, and we need to rotate that bottom one. So in this case it was 360 divided by, in this case it's 12 teeth divided by 24, so that requires a rotation of 15 degrees. And there we have it, and that gives us the exact correct meshing. So that is the scenario 1, the most simple scenario, where it's relatively simple to calculate the correct meshing angles. Okay, let's look at the second scenario. In that scenario, what we've got is the top gear being rotated by a certain amount. Now it can be any amount really, but we'll just pick a number, like for example 31.5. Now as I rotate that gear in that direction, this gear will rotate in the other direction by a gearing ratio, so it's 5/3. So I have to put in minus 31.5 times 5 divided by 3, so that is the amount that this bottom gear will rotate by, and then I still need the 15 degree offset in order to get the correct angle. So the correct angle should be 37.5 or minus 37.5. So let's type that in, minus 37.5, and look at that, we have got a perfect meshing between those teeth. And that would be very hard to do just manually. If you're just rotating it, then you'll never find that exact angle. So there we go, that is scenario 2 solved. Okay, and the third scenario is where we've got an offset between the gears. So for example, I could put a 20 tooth gear at the top here on this lift arm, connect a 16 tooth at a 2-to-1 step like this, and as you can see the meshing of the teeth is not quite correct, so we're going to work out what the correct meshing should be. So like I said, what I do, I pretend that this gear is at the bottom below that one, then it rotates around anti-clockwise towards the direction that it's actually in, and I need to work out how much that 16 tooth gear will rotate by going to that position. And like I said, there's two effects. One is the rotation due to the meshing with the first gear, and the other one is the rotation just from the physical rotation. So what I normally do, I calculate the gearing ratio between the two gears, and I add on the physical rotation. So the gearing ratio in this case is 20 to 16. Then I add 1 for the physical rotation, so that is how many times this gear will rotate relative to this angle. So first I could also work out the angle. So the angle is going to be a 2-to-1 step, so that is the opposite over the adjacent in terms of tan. So it's 1 over 2, so that's a half. So I'm going to multiply that by a half inverse tan, so that's an angle of 26 degrees between this axle and that axle. That's going to get multiplied by 2 1/4 in order to get the rotation of this gear. So this gear will rotate 59.77 degrees as it moves from being vertical to being on the angle. And then I've got to add on that 11 1/4 that a 16 tooth gear needs to rotate in order for the teeth to mesh originally. So that gives me my final answer. So the final answer was 71.02 degrees. It should be the correct meshing angle. So let's try that. 71.02. And wow, look at that, meshes exactly. So that is the perfect mesh. So that concludes this scenario 3. That is how you calculate the correct meshing angle for an offset gear. Okay, so that's my overview of how to calculate gear meshing angles if you don't want your gears to mesh nicely on a designer program like Studio. Now, of course, the angles that I calculate, like for example the 71.02, you can add any multiple of these gears to that. That angle will work as well. So, for example, if we've got 360 divided by 16, that is the angle between the teeth. That's 22.5. I can add 71.02 to that, and then of course 93.52 will work as well. And of course, it might depend on the required relative axle angle. So in this case, the axle angle is a lot more aligned with this axle, and of course there is there's 16 different meshing positions that a 16 tooth gear can take. And of course, with the axle symmetry being 4-way, there's really only 4 that give you different relativities between the gearing axles, and in some cases that can be important. So anyway, I hope you like this video. Please like and subscribe, and yeah, we'll see you next time. Thanks for watching.